Hello everyone. I have brought a new presentation today, a small one, which is based on the IUPAC nomenclature of haloalkanes and haloarenes, that is for class 12th organic chemistry chapter from the second book. Now, in this chapter, we'll be studying about alkyl halides, that means RX we generally write, alkyl halides. They are also called haloalkanes and aryl halides like this, where the halogen is attached to benzene. So let's get started. You will notice that I have taken examples from NCERT purposely, and common names are also specified. So you have to be very clear about them also, though they are limited, which is a good thing. But in the questions, they may give you the common name and they may ask you that draw the structure and give the IUPAC name. So the simple common names I must know about them. For example, N-propyl bromide. First example. Now N-propyl means a straight chain, no branching, and bromine is attached here. So if you write the IUPAC name, you are going to use the same rules. Find out the longest carbon chain, and once you do that, start numbering from the side from where the functional group is getting the lowest possible number. So the name is 1-bromopropane, a simple one. Next, the difference between the first and second is the position of the functional group, that is halogen. Here also it is propyl, but the functional group is attached to second carbon. So when you have two methyl groups attached to same carbon, you make use of the prefix iso in common naming. For the main compound, you cannot use iso for IUPAC naming. That can be used for substituents, iso, neo, but not for the main compound. So this is isopropyl chloride. This is the common name. And IUPAC name, much easier. I'll start numbering 1, 2, 3. You number from any side, you are getting 1, 2, 3, 1, 2, 3 only. That means the halogen is coming on the second carbon from both the sides. So it becomes 2-chloropropane. Easy. Next is two methyl groups on the same carbon again. So iso is used. Again, this is a common name. And there are total 4 carbons in the molecule. So you call it isobutyl chloride. Now, IUPAC naming. For every compound, you need not know the common name, but those which are given in NCERT, specifically, their common names are specified, you must know at least them. So, this becomes 1, 2, 3. 1-chloro. On second, you have methyl. So, 1-chloro, 2-methyl propane, because as you can see, the longest carbon chain is of 3 carbons. If you do it by writing, when I am explaining, just keep your register with you and start writing. You can stop the video anywhere and look at the examples carefully and then resume watching video, and that will give you more clarity. But do write everything so that you get a very good practice. Now, you have haloarene example. This is bromobenzene. The common name, IUPAC name, both are same, because for many compounds, it happens that the IUPAC and common names, they are same, like phenol, another example. That will not belong to this chapter, but just an example. So, haloarenes we are discussing. And here you have two bromo atoms attached to the benzene. Now, you can start clockwise or anti-clockwise, anyhow, in the cyclic compounds. The idea is to give the lowest possible number to the carbons having the halogens attached to them. So 1, 2, 3. Or if you come from the other side, again it is 1, 2, 3. So 1, 3 from both the sides. So the IUPAC name will be 1,3-dibromobenzene. And common name is also easy. M is meta. So if this is the carbon that I am choosing as a reference, then this carbon and the next two carbons are ortho, next two are meta, and exactly opposite is called para position. So as you can see, the after this the next Br is at third carbon, so this becomes meta dibromobenzene. Again, ortho, meta, para terms are not used in IUPAC, so this is again a common name. This is the IUPAC name. Next example. 1, 3, 5. You start counting from any carbon which has Br on it. You will get the same numbers, clockwise, anti-clockwise, anyhow, 1, 3, 5. So no confusion about it. It becomes 1,3,5 tribromobenzene. And this is also written in common naming as sim. That means symmetrical. You can see the symmetry here. So this is symmetrical tribromobenzene. Sim is the prefix used. More examples. Another simple one. You have to follow the simple rules. Choose the longest carbon chain, then start numbering from the side from where all the substituents, functional groups, everything is getting the lowest possible number. So this becomes 1 chloro. On the second, you can see 2 methyl groups, 2 dimethyl, and the chain is of 3 carbons. So it becomes 1 chloro, 2 dimethyl propane. And the last on the slide, again a very simple one. Everybody can answer this. I'm very sure about it. So it is 3-bromo-propane. More examples. This is something different, maybe confusing if you don't do it here. That's why purposely I have brought it here in my presentation. See carefully, ethylidene chloride and ethylene chloride. The difference is, here this is also a dichloride. There are 2 chloro. This is also a dichloride. But see the position of Cl. Eth means 2 carbons. That is common in both of them. So where is the difference? The difference is in the placement of the halogens. They are on the same carbon. That is called gem dihalide. And if they are on adjacent carbons, we call them vicinal or Wick dihalide. Geminal, vicinal. So this is ethylene dichloride, common name. And this is ethylidene. Because it is given in NCERT, they may give you the ethylidene and ethylene dichloride names. So be very careful about such examples. And when it comes to IUPAC naming, then obviously it is very easy. This is 1,1-dichloroethane and this is 1,2-dichloroethane. Then you will come across a table in your NCERT. In this, very good examples are given along with their common names and IUPAC names. So do write them one by one in your register. Like first one. The first one is CH3, CH2, and then the CH is having the Cl attached to it. That's why it is written in a bracket here. So it will be written as CH3, CH2, CH3, CH2, then it was CH with Cl attached to it and another CH3. So when you write like this, it automatically becomes very easy to write the IUPAC name. Now you can start numbering. 1, 2, 3, 4. Why did I come from this side? Because this carbon having Cl was getting the lower number 2. So it becomes 2-chlorobutane. 2-chlorobutane. I cannot call it iso in common naming also because the 2 methyls are not attached to same carbon. So it is not iso. Be very clear about it. Second, same way draw this. Just giving you an idea. So the common name is secondary butyl chloride. That is also easy to understand. Butyl means 4 carbons and secondary means when you draw 4 carbons, on the second carbon from any side you put Cl. Now this carbon which is having halogen is attached to 2 more carbons, so it becomes secondary butyl. So that is the idea how the common names are given. Same way try for the second one. CH3 whole thrice means they are attached to this carbon. And then CH2Br. So carbon which has CH3 thrice attached to it. So it has to be like this. If they are in a bracket, that means they are attached to same carbon. And then you have CH2Cl or Br, whatever is given. And then it's easy. 1, 2, 3. So it becomes 1 bromo, 2 dimethyl propane. So the idea is, if you draw them like this and then try, it's not going to be difficult. So try this table like that. I'll discuss about this type of compounds. Vinyl chloride, allyl. Vinyl means the functional group is attached to the carbon involved in a double bond, and allyl means it is attached to the carbon next to the double bond. So this is the double bond and this is the next carbon to the double bond. It could have been on either side. So it becomes allyl. So these are the common names and they are often used. So you must know vinyl and allyl. Once you know what is vinyl, you will draw it like this. The name is simple, that is chloroethene. And same way here, it is propene on the first carbon. From this side, you have bromo. Now the confusion is whether you are going to give number 1 to this carbon or this carbon. So the priority series will help. When you have a double bond and you have a halogen, double bond gets the preference. So it will be 1, 2, 3. So it becomes 3 bromopropene or prop1ene. That's why 3 bromo. Same way you have orthochlorotoluene. Ortho positions, toluene means benzene with CH3. Ortho position on either side you can put Cl. So it becomes 1 chloro 2 methyl benzene, or you can call it 2 chlorotoluene also. Another interesting example. Now generally I ask whether it is alkyl halide or aryl halide. So you should know that in this particular example, the halogen is attached to the carbon in the side chain. It is not attached to benzene. So it is an example of alkyl halide where this acts as a substituent. So the name will be IUPAC name I am talking about. It is chloro and this is phenyl. Both are the substituents on one carbon, which is methane. So alphabetically when you write, chlorophenyl methane is the name. And common name, benzyl chloride. Benzyl means this group, benzene attached to CH2. So benzyl chloride is the common name. Very important. It is generally used in asking questions that draw the structure of benzyl chloride and give the IUPAC name. Like that you can expect. Then you have this compound. This is commonly called methylene chloride, CH2Cl2. Name, IUPAC name is easy. This is dichloromethane. This is chloroform, trichloromethane. This is bromoform, tribromomethane. This is carbon tetrachloride. This carbon tetrachloride is obviously common name. So can you tell me the IUPAC name? Yes, everybody can tell. It's easier. It is tetrachloromethane. Carbon tetrachloride cannot be the IUPAC name. In IUPAC name, we write halogen first. And then you have another simple example, 1, 2, 3. So it is N-propyl fluoride, common name, IUPAC name, as you can see, 1-fluoropropane. Okay, let's write IUPAC names for these compounds now. In these compounds, what is common is they all are showing you the bond line structure and they have a double bond and halogen. So first thing is you have to be careful. You have to draw the structure for yourself or put carbons like this for clarity so that you can identify the longest carbon chain. And when there is a double bond and there is halogen, the preference is given to double bond. So I'll start numbering from the side from where the double bond is coming closer. So it becomes pent2ene and fourth carbon is having bromo. So the name would be 4-bromo-pent2ene. Second example, you have carbon, 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 4 carbons in the main chain. The main chain should include the carbons involved in double bonding. Again, start numbering from this side. This is but1ene. So third carbon is having bromo and second carbon is having methyl as a substituent. So the name is 3-bromo 2-methyl but1ene. Next example, third one, you have carbon, 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 again 5 carbons in the main chain. If you number from this side, 1, 2, 3, the double bond bearing carbons are getting the number 2 and 3. So I'll prefer this side. numbering, and it will be again pent 2-ene with two substituents, one bromo and one methyl. So according to the carbons where they are placed, it becomes 4-bromo 3-methyl pent 2-ene. Let us see the next example now. 4 carbons in the main chain. Now something interesting here, you number from any side, even if you number from this side or from this side, the double bond bearing carbons are getting number 2 and 3. So in any case, it is but2-ene. Now I will start numbering from the side from where the other substituents, bromine and methyl, they are also getting the lowest possible number. So in this case, if I number from this side 1, 2, 3, 4, it is still but2-ene. From both the sides, same number is coming for the double bond. So I'll start numbering from this side so that the carbons which are having substituents are also getting the lowest possible number. So the name is 1-bromo 2-methyl but2-ene. Let's do the fifth example. 1, 2, 3, 4. And if you go from the other side, it is 1, 2, 3, 4. So again, from both the sides, it is but2-ene. So we'll number from this side, same reason, so that the substituent bromo, that carbon which is having the substituent, gets the lowest possible number. So the name is 1-bromo but2-ene. Last example, 1, 2, 3. In this case, I should come from this side only because here it is propene, right? What will happen if you go from the other side? This becomes prop2-ene, right? So prop1-ene obviously will prefer, same reason. And you have two substituents, methyl and bromo. So same way you can write the name here also. I'll start numbering from this side. So it becomes 1, 2, 3. 3-bromo 2-methyl propene. Even if you don't write prop1-ene, it is okay, understood that in case of propene there are 3 carbons. So in any case it has to be 1, 2, 3. If you come from the other side, it would have been, the double bond would have been here, then I would have numbered from here. Same thing. Now here you can see that a different type of question based on IUPAC nomenclature is asked. They are giving you the IUPAC names and they are asking you to draw the structures, write the structures of these compounds. So let's try with the first one. 2-chloro 3-methyl pentane. You can see the pentane is the parent compound. So 5 carbons I will be writing 1, 2, 3, 4, 5. Pentane, single bonds. Start numbering from any side and then stick to it till the end. So if I number from here 1, 2, 3, 4, 5. On the second carbon put chloro, it is 2-chloro. On the third carbon put methyl, it is 3-methyl in the name. And then complete the 4 bonds of each carbon by putting hydrogens. 3, 1, 1, 2 and again 3. So this is the structure for the first compound asked in the question. Let's try with the second one. The second is 1-chloro 4-ethyl cyclohexane. So cyclohexane is this. Don't get confused between this and benzene. Start numbering from any carbon. Suppose I number from here. This is 1-chloro, and then clockwise or anti-clockwise, come anyhow. On the fourth carbon it becomes 4-ethyl. So this is the structure for the second compound. Let's try the third one quickly. Heptane is the parent compound, so there are 7 carbons. 1, 2, 3, 4, 5, 6, 7. On the fourth carbon tertiary butyl and third carbon iodo. Third carbon, I number from the left side, iodo. Fourth carbon, tertiary butyl. So butyl has 4 carbons. Tertiary means this carbon, which is attached to the main chain, should be attached to 3 more carbons. So it becomes tertiary. This is the tertiary butyl group. Now complete the 4 bonds of each carbon as you know how to do it. H, H, CH2, CH2, CH3. That's it. I hope you are finding it easy now. Next is 1 bromo 4 secondary butyl 2 methyl benzene. So benzene is the parent compound. I'll draw benzene. 3 alternate double bonds on any carbon. Number 1 bromo. Then start numbering clockwise, anti-clockwise. Fourth carbon is secondary butyl. Butyl again 4 carbons. Secondary means this carbon which is attached to benzene is attached to 2 more carbons directly. Butyl has 4 carbons. So put this hydrogen will come here. This is secondary butyl on the 4th carbon, and second carbon is having methyl. Easy to draw the structure from the IUPAC names. And the last on the slide is 2 chlorophenyl 1 iodo octane. Octane means 1, 2, 3, 4, 5, 6, 7, 8 carbons. 8 carbons in octane. On the first carbon, put iodo. On the second carbon, 2 chlorophenyl. Phenyl is benzene when it is a substituent. And when you number it, the carbon which is attached to the main chain is 1 and on either side it is 2. So on the second carbon I have to put chloro. So here I will put Cl. This becomes 1, 2 chlorophenyl 1 iodo octane. And now you can, this is a single bond. Now you can complete the 4 bonds of each carbon by putting hydrogens. CH3, CH, H2, 2. So this completes the structure. Now we have to write IUPAC names of the compounds, given compounds. This particular example I have taken from NCRT exercise because there were some particular examples students were facing problems with. So I thought of discussing them also here. So purposely I have selected a few out of them. So let us write their IUPAC names. But the first thing, when you have to write the IUPAC names from the given formula, and the formula is condensed formula, it has some brackets, some numbers written out of the brackets, you have to be very careful. First you have to draw the structure well and make it easy for yourself, then you try with the name. The way it is written here, if you try from here directly, you may go wrong. So you should know how to draw the simple structure for yourself. For example, the first one, you have CH3, then you have CH, and then you will notice there is a bracket. That means the CH3 is attached as a substituent here. Then you have one more CH, then you have Br, and again CH3. I hope it seems very easy now. It is actually very easy now once you draw it like this. Start numbering from the side from where the substituent bearing carbons are getting the lowest possible number. So it is getting 2, 3, 2, 3 from both the sides. So what will I do? I'll start coming from the side from where the alphabetically coming first substituent gets the lower number. So it becomes, it's on second carbon, 2 bromo, 3 methyl butane. That's the name. Let's start with the next one. CH3, C, Cl attached to it, bracket means substituent, and then you have C2H5 in another bracket. So I'll put it here. Whether you put Cl above and C2H5 below or vice versa doesn't matter, same thing. CH2, CH3. Sometimes when some structure is confusing, just check that all the carbons in the structure have 4 bonds total. All the carbons, suppose in this particular example, if you see the carbons, there are 4 carbons in the chain. I'm not saying this is the main chain. That is the twist here. You have to be careful when you draw the structure. If I go like this, there are 4 carbons. But if I consider this as the main chain, I hope you can see there are 5 carbons. And then on the third carbon from any side, when you start numbering, it is having chloro and methyl in it. So if you want to make it simpler, you can write it for yourself like this also. C2H5. Then this carbon. This carbon has one methyl on it, as you can see, and one Cl on it. And then you have CH2, CH3. Now the main chain. The point here is, it's not necessary that every time they will give you the main chain as a straight chain like this. You have to identify which is the longest carbon chain. Now the name is, if I come from this side, 1, 2, 3, third carbon. From this side also third carbon. So number from any side, both the substituents are on the same carbon. So the name is 3-chloro, 3-methyl, pentane. Third example, you have CH3, then you have CH, double bond, another CH, yes, and then you have one more carbon, and this carbon is having Br, and this carbon is having 2 methyl groups, so they would be like this. When I write the name, I have to be careful that carbon which are involved in double bond, they are a part of the main chain. So I hope you can see it clearly that from where to number. When you have alkyl substituent, when you have halogen as a substituent and a double bond, the preference is always given to the double bond. So I will start numbering from this side. 1, 2, 3, 4, 5. Now it becomes pent-2-ene. And there is bromo. So 4 bromo. Again 4 methyl. And then in continuation, pent-2-ene. That's the name. Next is CH3, CH2, CH with a methyl substituent in bracket, another CH, C2H5 in the bracket, and Cl. Now the same thing, I have to search for the longest carbon chain, and the carbon having halogen should be a part of the chain. So this is the longest carbon chain. Whenever in the name you have, suppose you don't consider this as the longest carbon chain and you go straight like this, then many students will write 2-ethyl. Whenever you have 2-ethyl in the name of the compound, check it once more. Second carbon has ethyl, that means the longest carbon chain is the one which has that C2H5. So be careful when you are doing such examples. So this is the correct carbon chain. I can see 1, 2, 3, 4, 5, 6 carbons. So it becomes hexane, all single bonds. When you start numbering from this side, 1, 2, 3, on the third carbon there is chloro, fourth carbon methyl. And when you come from this side, again you have 3, 4, but methyl and chloro are the substituents. So alphabetically chloro comes first, so I'll go from this side. So the name becomes 3-chloro, 4-methyl, and then you have 6 carbons, so it is hexane. Next one, when you have the CH3 thrice and then 1 carbon, a very common mistake that I always discuss in the class, I have seen students writing CH3 whole thrice like this, CH3, 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 then they put this 1 carbon and then CH2. So completely wrong, because CH3 can never come in the middle of the chain. These carbons are having 5 bonds. This has only 2 bonds. Impossible. So how will you check? You have to see that each carbon in the structure has 4 bonds in total. So let's draw the structure of this. CH3 whole thrice and a carbon means this carbon is attached to 1, 2 and 3. 3 methyls. Then you have CH2. Till here I had drawn. Then CH2. Then one more CH. It has Br. And then C6H5. That means the phenyl group. Now you have this Br in the carbon chain, side chain, not attached to benzene. So the compound is haloalkane. And this is a substituent here. Start numbering from here. This is 1 bromo, and then alphabetically methyls will come first. So 3,3-dimethyl, 1 phenyl again, and the main compound is butane. So 1 bromo, 3,3-dimethyl, 1 phenyl, butane is the name. Second last, M means meta. Metachloro, CH2, there is CH2 as you can see here. There is Cl and there is C6H4. That means this is attached to benzene. Meta position, wherever you have a particular attachment, then this would be meta corresponding to that. At meta position, CH2, C and then 3 methyls. 1, 2, 3. Now you have to name the compound. Important one, the halogen is in the side chain. But if I consider this as the main compound and this whole as a substituent, then there is a very complex substituent, a very big substituent. In such cases, what you have to do, you have to consider the benzene as the main compound. And this is a substituent, this is also a substituent. When you have to number the complex substituents of this type, consider this as a mini compound. The carbon which is attached to the main compound should be numbered 1 and then choose the longest carbon chain. This is propyl. In propyl on second carbon you have methyl twice. So this particular small complex substituent becomes 2,2-dimethyl in continuation, no gap, propyl. This is the name of the complex substituent. It's on 1, 2, 3, third carbon. So 3 dash. And you have this which is called chloromethyl. This is chloromethyl. Right. So you will see for the alphabetical order, C of chloro. So that will come first. So the name of the compound, let me quickly draw it again so that there is no confusion. This is a substituent. Here you have CH2. This carbon is not there. You have CH2 and then 1, 2, 3. 3 methyls. For this I have already told you the name. It's on the third carbon. First carbon has chloromethyl. So the compound is benzene, and on the first carbon you have chloromethyl. On the third carbon you have this complex substituent, and then you end it with benzene. That's how you write the name. Last one. This is O bromo. That means ortho position has bromo. Whenever you have meta, ortho, para in the name, it is very clear that there has to be benzene, right? So yeah, I'll take you back. Yeah. So you have C6H4. Here is benzene. Put Br anywhere and then see the ortho position. At ortho position, you have to put this substituent. This is the ortho position. So you have CH, CH3. You have CH2, you have CH3. This is clearly bromo, benzene. and along with the bromo on benzene you have another substituent. So the carbon attached to the benzene main compound is numbered 1, and then choose the longest carbon chain. 3 carbons, propyl, but on the first carbon you have methyl. So the compound becomes 1 bromo. On the first carbon you have bromo. Alphabetically this will come first, so I am giving number 1 here. And then on the second carbon, which is ortho position, you have 1 methyl propyl. This is how you write the name of the complex substituent, and then end it with benzene. That's the name of the compound. A few more IUPAC names you have to give, easy ones. I have purposely taken all the examples from NCERT, and then there is no dearth of examples. You can do more from the other reference books available. There will be so many worksheets, examples available on the net, and NCERT exemplar is also very good to practice. If you do NCERT's class 11th and 12th thoroughly along with exemplars, that will be helping you in competitive exam also, and your score is going to be very good in your CBSE exam as well as competitive exam. So do it by writing. A lot of written practice is required. Let's take the first one, CHF2 and then CBrClF. So there are 2 carbons I can see. On the first you have CH and you have 2 fluorines. On the second you have Br, F and Cl. So when I write the name, I have to see there are 1, 2, 3 fluorines on first and second carbon. Now this has to be first and second like this or the other way, that we have to see. On the first carbon there are 2 substituents, if I number it like this. On the second carbon there are 3 substituents. So the number 1, 1 and will come twice, and number 2, 2 is coming thrice. So it is better to number it from here, 1, 2. That way I'll write number 1 thrice and number 2 twice only. So lowest sum rule. Let's draw it quickly again. You have CH, F, F. You have C, Br, Cl, and then again one more F. So I was saying, if we number from this side, then it becomes alphabetically 1 bromo, 1 chloro, 1, 2, 2 trifluoroethane. Let's take the next example. ClCH2, C triple bond C, CH2Br. Now you have to see from where the triple bond is coming closer, because when you have unsaturation along with halogens in the compound, you have to give preference to the unsaturation, that is double or triple bond, right? So I'll start numbering from this side. Suppose I am getting butene. I number from this side, I am getting butene. So I can number from any side. Which one to be preferred? From where the halogen which is coming alphabetically first is getting the lowest number. So this is something that I am going to prefer. So it becomes 1 bromo, 4 chloro, but 2 ine. 1 bromo, 4 chloro, but 2 ine. Next, you have CCl3 thrice on this carbon and one more Cl. Carbon is only one in the middle, Cl, and then you have CCl3, CCl3, CCl3. I have taken the examples which students find confusing year after year. I have seen that, so I chose some of them. Okay, so here the longest carbon chain is 3 carbons. This is propane clearly, and propane has this chloro, 3 chlorides here, 3 here, and this is trichloromethyl substituent. So now it is easy to name it. 1, 2, 3, come from any side, it's going to be 1, 2, 3 like this. So the name would be, I'll write 1, 1, 1, there are 3 chloro here, 2, 1, 1, 1 with comma, separated by comma, 2, and then 3, 3, 3. 7 Cl atoms are here on these positions. So heptachloro. Understand this. This is very important. Hepta means 7. And then on the second carbon you have this. This is called trichloromethyl. And then end it with propane. So the name is 111 2 3 3 3 heptachloro 2 trichloromethyl propane. Next, second last, CH3 C, CH3C. Then you have these groups. The group is coming twice. So you have C6H4. Para position has Cl. Para chloro is written. Same way you have here. Para position has chloro. Then you have CH, Br, and then CH3. The main compound has 1, 2, 3, 4 carbons, so it is butane, the parent compound. On second carbon, you have this group twice. On third carbon, you have Br. Okay, it is, when you write alphabetically, 3 bromo, 2, 2. On second carbon, you have 1, 2, 3, 4. 4 chlorophenyl we call it. But this is a complex substituent, so I cannot write di. You have to write after this dash bis and then start the bracket. Bracket when you are starting, in the bracket you will write 4 chlorophenyl. This group is coming twice, so I wrote bis. And then butane. This is the name of the compound. And the last one is CH3 whole thrice on this carbon. Carbon has 3 methyl groups. Then you have CH. Then you have double bond CCl. Then you have benzene C6H4. Means there are 2 substituents. One this side and the other is para position has iodo. Now this is the longest carbon chain which has 2 methyls, 1 chloro and 1 4-iodophenyl. I hope you can write the name yourself now. Start numbering from this side. So it will be 1 chloro, 3,3-dimethyl, 1 methyl here and 1 here. And again 1 in the bracket 4-iodophenyl butanene. So this completes the discussion about these type of compounds. I hope the presentation is going to help you. Do a lot of written practice. Your concepts will be very clear. All the best. Thank you.